Hey, welcome back to RamZland. Today I want to share with you my phantom bottle. Check this out. So all I'm using in this investigation is a tub of water, a wine bottle, a beaker with a little bit of distilled water, of course a microwave, and some food coloring. The first step is just to add some food coloring to your tub of water. I'm going to add a little bit of red food coloring and stir it until all the food coloring diffuses evenly in your tub of water, just like that. Next, pour a little bit of water into your glass bottle. That's plenty. Now with just that little bit of water, lay your bottle sideways in the microwave and set it for 3 minutes. At this point, that little bit of water inside of your glass bottle is coming to a boil. Now, of course, this is my favorite part. Make sure you've got a protective glove on because this bottle is hot. Pour out the remaining water that's in the bottle and slowly put it in your tub and watch what happens. Look at that water. It's climbing. Look at that. How is that possible for the water to climb in the bottle? It's as though it's overcoming the force of gravity. It's still climbing. I'll hold it this way so you can see it. Look at that. You can see it will go all the way to the top. What's allowing the water in the tub to climb in the glass bottle? Think about the amount of pressure that's in the bottle after I take it out of the microwave and compare that to the amount of air pressure that's in the classroom. Just look at that, it's almost all the way to the top. Isn't that amazing? What's going on in this lab? So this is really a classic atmospheric pressure demonstration. In this classroom, I have about 14.7 pounds of atmospheric pressure acting on every square inch of my body. But when I take a little bit of water and boil it in the microwave, as that water turns into steam, it starts to convect out of the glass bottle. And the more hot air that convects out of the bottle, the less pressure there is in the bottle. And then when I invert it into my vat of water over here, the atmospheric pressure in the classroom, 14.7 pounds per square inch, pushes down on the water in the tub, forcing it up into the bottle because there's less air pressure in the bottle since all that hot air convected out of it in the microwave. And now, with less air in the bottle, the air in the classroom can push down on the water in the tub and force it up into the glass bottle in this fun and easy demonstration. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.